We're moving into 1.3 today, but I want you to start with a homework quiz from 1.2. So in the number 1 and 2, you are comparing these two. Are they greater than, less than, equal to? Number 3, you're ordering them least to greatest. Come back when you have tried it out. And so there we go. There are the beautiful answers to these questions, right? And now we're ready for lesson 1.3. Okay, today we're going to answer the question, can you add integers? And this begins on page 18. I'm sure you had lots of practice adding integers last year. So we're going to be dealing with all kinds of integers though, right? So not just counting numbers, not just whole numbers, which are all positive or 0, right? But also those opposite of the whole numbers, the negatives, which is why we're dealing with integers again. When you hear that word, that's what that is. So right here we have 1 plus 2. Not hard, right? So this is where you could use that red pen. You could write 1 plus 2, and then in red equals, you could answer it. 1 plus 2 equals 3. 1 plus 2, right, equals 3. Not tough. We could ask a kindergartner that one, right? How about negative 5? Now this is the tricky one. This is what we could not ask all kindergartners. Maybe there are a few who could do this, but not most of them, right? Negative 5 plus negative 3. And Brianna? He thinks it might be 2? Negative 2, because 5 minus 3 is that, right? That's what she's saying. Marlena? Is it? Your name again is? Yes. Oh, that's right, Adrienne. I'm sorry. Okay, go ahead. She thinks it's positive 8. Does that feel kind of logical too? When we multiply two negatives, what do we get?
Negative.
Positive. But in this case, we're adding. So something slightly different than that. And Luca?
Negative 8.
Negative 8. Very good. Negative 8. So what did you do to get negative 8?
Well, so when I add negative integers, I normally switch that add sign with a minus sign and take away the negative symbol. So I'm just doing negative 5 minus 3. I go left.
And you go more left. He says I'm going left, negative 5, and I'm going more left, negative 3. That's what he's doing when he's adding. A negative takes us left on the number line, right? So up here we're starting at 0, we're moving to negative 5, and then we're going more negative. 3 more negative. So it's the same as just taking away those negative signs and adding those two numbers, right? 5 plus 3 is 8, and then give it a negative. So when you have two integers that have the same sign, look at the first example. These two have what sign? What's the sign in front of this 1? Positive or negative?
Positive.
So it's the invisible positive sign, right? When you don't see a sign, we could imagine there's a plus 1 in front of there. And the sign in front of the 2 is really clear to see. It's a plus sign too. So those two integers are positive. We just add them up. In that case, we're moving to the right on the number line. In this case, the second example, we have two negatives. Again, we just add them up, but we're traveling left on the number line. So when you add integers with the same sign, we simply add their absolute values and then give them the sign that they share. Use their common sign in your sum. So now how about adding integers with different signs? So let everyone think for a second. Take this down and write down what you think these sums are. It's all addition right now, so write down what you think they are and then we'll talk about it. The first is 6 plus negative 7. They do not have the same sign. 6 is positive and negative 7 is negative. So if they had the same sign, we know what we would do. We would just add them and get 13, right? So this feels like it must be different because they don't have the same sign. So rather than adding them, what operation will we use? Everyone?
Subtract.
Good, subtraction. And so now the question is, how do you subtract? You know, the 6 is so positive. Feels like you should say 6 minus 7, kind of, doesn't it? Which you could, I guess you could say. But what do you do, Kyle?
We you start at the 6 and then go 7 that way, so
Okay, good.
8 of white.
He says you could start at the 6, if you're imagining again the number line, start at the 6 and travel 7 to the left, he says. So 1, 2, 3, 4, 5, 6, 7, and there you are at -1. Now, it's nice to have that picture in your mind of the number line and how you're moving. That's awesome. That's good. But when we're dealing with big numbers, it's kind of a hassle to be thinking of the number line. So what strategy could you remember in your mind if you have to add these numbers that have different signs? Mark?
You take the 7 and put that in front of the 6, and then you subtract the 6 from the 7, whatever the answer is, you put it in.
Very good. Okay, so he wants to subtract the 6 from the 7. Doesn't the 7 feel like a bigger number? Even though is it bigger if it's a -7? Really, the greater number is the positive number here, but it feels bigger, and we call that absolute value. That's what that is. So you take the one that has the greater absolute value and subtract the one that has a smaller absolute value. And then in this case, we gave it a negative sign, right? Let's see what happens in B. We have -4 plus 9. So think about how Kyle did that with the number line. And think about what Mark just said too, about how you could subtract the smaller absolute value. How does that work here? Jensen? Thumbs up if you agree. She says 5. It is correct. Good. So now that's a positive number, see? So sometimes when we add numbers with opposite signs like this, we get a negative, and sometimes we get a positive. So why did we get a positive this time, Jensen?
Because, well, I didn't do it.
How'd you do?
I did 7, and it has a bigger absolute value, so I put the minus on, but then the 4 is a bigger.
Okay, so she's saying that in this example, the number that has the biggest absolute value is 9, and it's positive. So look at how our answer is positive, right? And in the first one, she said the number with the greater absolute value was 7, which is the negative number, and so the answer was negative. So it seems that the one with the greater absolute value causes the answer to be, or has the same sign as our answer. -7 was the greater absolute value, and our answer was negative. +9 is the greater absolute value, and we have a positive sign. That's exactly true. Very good. I'm glad you saw that. So we would say, this rule is kind of tough to say. We're going to subtract the lesser absolute value from the greater absolute value, and then we use the sign of the greater absolute value, just as Jensen said. That's kind of a lot of words to say. So often I'll just use a little phrase that isn't perfectly mathematically accurate, but it reminds us of this. I'll say you subtract the smaller from the bigger and take the sign of the bigger. Let's look up here. If I subtract the smaller, that's 6 from the bigger. 7 minus 6 is 1, and then take the sign of the bigger. Now, is -7 really bigger than 6? No, but when I say smaller and bigger, I'm talking about absolute values. Which one's bigger that way? Okay? This works for number B too, problem B. Take away the smaller number 4 from 9, right? Which is 5, and give it the sign of the bigger, which is positive. So there you go. Some addition properties. The identity property of addition. So, what does that mean, the identity? -3 plus 0. Right? -3 plus 0 is -3. So when we hear the word identity, we think of like identification cards, right? Maybe you've had an ID card. If you've been at St. John's, usually after picture day, they give everybody an ID card, right? And it shows you who you are, right? So imagine if I am -3. How could I stay the same as myself? What could I add to myself and stay the same? 0. Same is true for you all. And you can be who you are, and you would stay the same if we add 0 to you. And so the identity property of addition just says that when you add 0, you're going to, what? Stay the same. When you add 0 to an expression, it doesn't change the value, does it? Kind of easy. The sum of a number and 0 is the number. So when we talk about the properties, we usually start with an example like this, but this is true for all numbers. So when we make a rule in math, we use a variable to represent all numbers. Who could finish the rule here if we start with A? How can you show the identity property of addition as a rule right now with the letter A? Skylar.
A plus 0 equals 5.
Excellent. She says A plus 0, and she said equals A. And there it is as a rule. And A could be any number. Okay? When you see 0 being added to something, you could say, that's the identity property of addition. The second property is the inverse property of addition. Our example is 5 plus negative 5. What happens when we add numbers that are inverse? Now, that word inverse is not one that we use a lot in our everyday world, right? So what word might somebody use in the everyday world? We're adding opposites. Like yesterday we talked about opposites. So what happens when you add two values that are opposite, Emma?
You get 0.
You get 0. So we can write that as a rule, right? Could you complete the rule, Emma?
A plus negative 8 equals 0.
Excellent. A plus negative A equals 0. Writing it in words, we could say the sum of a number and its opposite is 0. Those are inverses. This is such a funny little property. We don't talk about it as often because it's so straightforward. It's so evident to everybody. It's called the closure property of addition. And it says 4 plus 9 equals 13. How about next year if I came back and looked at this again, 4 plus 9 would equal 13. It always equals 13. Close the door on that. That's it. It just says that if you have two numbers that you know and you're adding them, is there one number that will be their sum? Yes. It will always be 13. It's not going to change next year, or when you have kids and they go to school, 4 plus 9 will still equal 13. Okay? So you can see why we don't talk about it too much. It's pretty clear. You've been doing this your whole life. The sum of any two numbers is a number. In the case of integers, the sum of two integers is an integer. And this is in order to show this, we have to show more than one variable, actually. Who thinks you might be able to finish this rule? Cooper.
B plus B
Equals, very good. A plus B equals C. Adding any two numbers gives you some unique number. So you have to have 3 different variables to show this as a rule. Okay? Good job. We're just going to do a couple of these together before you get down to working. There's 2 possibilities today. You may receive just something to simplify. Once again, there's no equation, there's no equal sign. So write your simplified expression underneath it, and then we'll evaluate next. So try it and come back and check your work. Okay, so 2 negatives added give us a larger negative, right? Larger absolute value. Okay, this one is kind of fun because what do you see right there? Opposites. So what property are we using here? Inverse property. We can simply actually say that becomes 0, and the answer is negative 54. You do not have to do use a lot of scratch paper. If you have opposites, they become 0 with addition. Okay? Let's evaluate. So we plug it in, right? Substitution. They gave you a algebraic expression. It has all those letters. And then they gave you values for each of the variables. So you start with what you see and then plug it in, and watch out for these negatives. They are what cause the problems, biggest problem. We'll walk through substituting this together. Okay, so A is what I need to substitute first. So what is A? Look over there. It is -7. So write down exactly what it is. Okay, plus, now I need the absolute value of B.
-5.
What is B? -5. So you put it in just as you see. Minus the absolute value of negative. Now we go see what is C. -1. So we put it in as you see it. Look at that. There are double negatives inside of there. But there was a negative here, so I put it down. And then I substitute C, which is also negative. Okay, so all the details are here. So let's start with, we've got to simplify orders of operations. Say simplify what first? Parentheses or grouping symbols, right? Absolute values are grouping symbols. So I'm going to bring this down and wait for the other stuff to get simplified. The absolute value of -5 is?
5.
Okay, do it really carefully, step by step. I can keep this as subtraction for the moment, okay? And now look at what's in there. Inside here I have negative of -1, which is the same as what? The opposite of -1, right? Or +1. Okay, so this is the absolute value of 1. And so sometimes people say, you know, add the opposite. We'll say that a lot this year. When you have a subtraction, you can always add the opposite. Okay, and now we still have one more absolute value to simplify, so bring this other stuff down. And what is the absolute value of 1? It is 1. Now, there, I have kind of a simplified expression, but I see subtraction here. And again, we're going to talk about subtraction tomorrow, but you have heard already in 6th grade that when you have subtraction, I just said this, what could we do? Add the opposite. So we can change this to adding the opposite. Since that was +1, it now became a -1. Okay? That's the same as subtracting 1. If you left it that way, it's the same thing. Okay, and now let's start left to right, right? -7 plus 5 is -2. So they have opposite signs, so we subtract the smaller 5 from 7 and give it the negative sign because 7 was a greater absolute value. Okay? -2 and plus -1. Now we're adding two numbers with the same sign. So we just have,
-3.
we add them and give it the negative, -3. So there's your answer. Good. Questions? There you go. And you actually have almost 50 minutes to work on this in class.